Hi, everyone. I realize I have two things going against me here. One, this is the last session before lunch. And two, I'm the guy coming to a tech conference to talk about AI. I'm sorry. Let's talk about the AI Cyber Challenge. If we can get this going here. No, we don't want that. First, just an overview of what AIxCC is. So AIxCC was a two-year competition sponsored by DARPA and ARPA-H from the US government. It was announced at Black Hat and DEF CON back in 2023. Ran for a year, had semi-final competition at DEF CON in 2024, and just concluded with the finals competition at DEF CON earlier this month. $30 million in prizes, trying to encourage teams to develop cyber reasoning systems capable of finding and fixing vulnerabilities in open source projects that are critical to infrastructure. So things at hospitals and water systems and everything that we depend on for our daily lives. And so OpenSSF's role in AIxCC, we're collaborators in the competition. DARPA reached out. We've heard that DARPA invests billions in programs like this, and only about 1 in 10 fully transition successfully into industry adoption. So DARPA brought us in to help provide the perspective of open source projects, open source maintainers, just to help improve the possibility that this is going to successfully transition. The outcomes of this are going to have the real impact that they're aiming for. That started with just advising the competition along the way. We formed a group that met with them monthly and gave feedback on how they were shaping the competition and what was looking to come out of it. And we'll talk a little bit more later about where we go from here from the results of the competition, how we're going to help with this transition process from research into open source projects. And just a small example of how the process so far actually worked, the engagement. This is the title slide from the stage presentation at DEF CON. And you notice it says patching. That's not how they started talking about things at the beginning of this competition. But they heard us loud and clear that the world does not need yet another automated tool to fill the queues of open source projects with automated reporting and make life more difficult for the maintainers, make more work for them, right? Patching was the key. So a recap of finals and how things went here with the development of these systems. First, just an overview. So the way the competition was structured, they took a set of, for the finals, 28 different open source projects, repositories, took a snapshot of them from a point in time, and then simulated ongoing development as it would naturally happen in those projects. Both a combination of real commits and also some synthetic ones where they introduce some vulnerabilities. So introducing things into these repositories to test and see if these systems could find them and fix them. To score in the competition, there's 4 different things they can provide. 1, proof of a vulnerability. 2, and weighted most heavily, successfully creating a patch that doesn't impact existing functionality of the project, a Serif assessment, or a bundle of some combination of those 3 things. I'm using some of their slides from the presentation, so apologies for the font, but here's an overview of some of the projects that were involved. Kind of a cross-section. It was focused on projects in both C and Java. And just to compare, this is the results from the semifinals that I talked about that ran for the first year. Green represents successful patches of vulnerabilities that were found in that first round of the competition. Yellow is where it was found, but it wasn't successfully patched. And then blue here was, not found, couldn't find. So this was semifinals. Now I'm going to show you how this transitioned to, given another year of development and focus on this, how did these systems evolve? A lot more green, and a much wider array of projects. So much more details to come. I'm not going to go through, line by line here, but there's all sorts of data that will be released to open source out of the competition. We can kind of pour through some of these things. But just a few metrics here. Again, comparing semifinals on the left here to the finals. Went from a 37% discovery rate to 77%. And you see the successful patching much higher, 61% versus 25%. And also the amount of time it took to run through and generate these patches reduced. In addition to the synthetic vulnerabilities that the competition was focused on, it was expected, and the teams could also score if they found real-world vulnerabilities in these projects. And 4 finals, they found 18 0 days and successfully generated patches for 11. I see my friend Greg back here. We have the question of why didn't we have any in C, and why was it less? More details to come as we get information. There could be many reasons for this, but what's happening now is responsible disclosure process and reporting with the projects, and we'll talk a little bit more about that in a moment. A little bit more data, again, combined all the project repositories, everything included that was being scanned, 54 million lines of code, and again with the 45 minutes to patch. So lots of data here, some really interesting results, and we will move on. Just wanted to highlight from the basically the 3 winning teams, first, second, and third place, and a few notes about each of their systems, and some differences between them that I thought were interesting. First place team was Team Atlanta. They called themselves Team Atlanta because they have a shared connection of Georgia Tech in Atlanta, where I'm from. The one interesting thing about their system, they didn't, if I understood it correctly, they didn't just develop one CRS. They actually had a combination of 3. And they had one part of it that was focused on finding the vulnerabilities, and that used one of the LLMs. But then they used a different one when they found the vulnerability to try to generate the patches. And they found that some were better at parts than others. So that was a pretty interesting finding. And if you go through and see the details of the score, far and away, this system was very successful and effective at finding and patching. Second, OpenSSF members, Trail of Bits, and their system called Buttercup, placed in second place. One note about them, they acknowledged on the stage at DEF CON, they classified themselves as probably the biggest skeptics of AI for this purpose going into the competition, and really over the course of 2 years kind of changed their thinking and changed their mind about it and really became believers. One interesting thing about their CRS, it is available to download and run on your laptop. So that's something you could go test out this afternoon if you'd like. And third, Team Theory. One unique part about their system, they did not make their system dependent on fuzzing. So they represented it, it was kind of more flexible, and they could run it against more things. And that's one of the things that I'm interested in learning is, beyond just focusing on this competition, what else can these systems do if they're not constrained by just trying to score for this competition, because they've been running them the past couple years just generally against different projects and learning about them and expanding the capabilities. So we're only just starting to realize what these systems can do. So where do we go from here? The finals competition is over. The teams have won their money. Part of winning by accepting prize money written into the rules is they were required to release their systems to open source. And so that's where we come in, and that's where we start from here. As we think about this, again, we found 0 days through the competition. We have these powerful tools. And a lot of what Catherine talked about this morning is there's the human part of it that has to be in the mix. Again, we don't just want a bunch of tools that are doing automated reporting and dropping things on the maintainers, right? So it's engaging with the projects as humans as we find things and start to leverage these systems in the ecosystem. And that's a real thing. Our Daniel from Curl here, a very popular LinkedIn post from earlier this year. You can see here, we still have not seen a single valid security report done with AI help. This is, I think, a very common perspective and opinion on AI's place in this world. So, what are we going to do about this? Let's engage with the projects as humans. Again, this is where we come in, because if left to DARPA, hey, government contractor cold calling project saying I've got some vulnerabilities to report to you, that's probably not going to work so well, right? But what if we change that a little bit? And through OpenSSF and our community here, and our partners, we're able to engage with the projects and say, hey, we're from the open source ecosystem, and we're here to help. What does that look like? So this is the program that we're in the process of kicking off, doing this engagement, starting with these vulnerabilities that need to be reported and the patches to share it with the projects. And it's a series of steps, right? Let's gather and curate and find the best, most impactful examples to set that great first impression with one of these projects that's been impacted, and educate about how we generated this patch, what the tools are behind it, represent that a human reviewed it to make sure it's not just coming straight from the AI, things like that. And together with our friends from OSTIF, you guys are in the room, hi. We're kind of engaging or designing a program in kind of multiple tracks of things. So the first one, here's the one I've been talking about, which is just engaging with the projects to start as we are able to use these systems to generate patches and have things to offer to the projects, engaging in the right way as humans. And then there's extended capabilities that come from this, and potentially, these systems can be refined and become a part of the development pipelines, helping to keep an eye on things as it's going. There's many steps to take before we get there, but this is what the goals of these programs are. So with that, I'm happy to take any questions that you have. Oh, and I wanted to show one more thing here, if I can. How do I get out of this? I mentioned things were released to open source. And here it is. The start of basically the whole archive of the competition, archive.AIcyberchallenge.com. Scrolling down here, you have access to the repos from each of the teams, as well as a repo from some tools that the folks organizing the competitions used to structure and set up and generate things for the competition. Interesting fact, this tool here at the bottom that wasn't a competitor CRS, it also found some 0 days that are going through the reporting process through its setup. And then mentioned before, but it's not just the CRSs that will be released. All of the data, the infrastructure from the competition, everything is being released to open source, so it'll be available if folks want to extend the research further. As it mentions here, access, use, test, use, and build on all these materials. So, any questions on AIxCC? What about false positives? Great question. So one, specific to the competition, they designed the rules and the scoring to really penalize false positives, to really emphasize that you had to have a solid proof of the vulnerability, and then if you're generating a patch, proof that it doesn't negatively impact the existing functionality of the system. When it comes to beyond that, the false positive, that's where I'm talking about the developer relations side of things and the humans in between. What we hope won't happen is, we take these systems and we're just running them and submitting everything that they spit out, but treating it more like this is a junior developer on the team that has done hours and hours and hours of research, and maybe they found something, but let's get a more experienced person in the mix to review the outcome before we go bother a project with it. Other questions? Okay. Well, thank you all very much.